Unit 10, Lesson 2, Lines Tangent to a Circle. We're going to focus on tangent lines and segments and rays, learn some properties of how these lines are going to be used to connect to the radius of the circle, and creating triangles, working with triangles. Should be hopefully pretty straightforward if we make good sense of what a tangent, line, segment, or ray is. And so let's define that first. A tangent basically is a line or a segment or a ray that is in the same plane of the circle. So it's not coming through from another angle, another part, another plane, and just barely touching the circle. It's in the same plane as the circle, and it touches the circle at exactly 1 point. So that means no, it's not passing through the circle like a chord would, rather it's just barely touching. So exactly and only 1 point. We would call line AB a tangent line, ray BA is a tangent ray, segment AB is a tangent segment. And this point B that is on the tangent line that touches the circle and is shared with the circle, this point B is referred to as the point of tangency. And that's just an important declaration to say, like, A is not the point of tangency, but B is on this line. All right? And so it's going to be useful to us because we want to make sure that we understand these ideas, this theorem and its converse, as it pertains to this point of tangency. So here line AB is tangent to the circle C, and with P is the point of tangency. That means that if this line is tangent to the circle C at point P, then it is perpendicular to the radius CP. All right? Not any radius, but specifically this radius that touches the line AB at that point of tangency P. All right? And if these are perpendicular, then that means that we know that we have right angles. It means that we can draw right triangles, etc., etc., etc. Conversely, if a line is perpendicular to the radius, then it is tangent to the circle C. If AB is tangent, it intersects point P, which is on the circle, in such a way that it is perpendicular to the radius, then this line is a tangent line. So we had to be careful there to say as long as P is on the circle, because if it's just perpendicular to that segment, right, that doesn't make AB a tangent line, all right? It's crossing through and it touches at 2 points. But if point P is on the circle and this segment is perpendicular to that radius, then that means that AB is tangent to the circle. All right, so we're going to think of that forwards and backwards. If we know that it's tangent, we know we have right angles, and then we have all sorts of things that we know about right angles. And then if we make right angles, then that tells us something about the line being tangent or not. All right, so for example, here we're going to find the value of x, knowing that ML and MN are tangent segments. Well, if ML and MN are tangents, then that means that this angle and this angle are right angles, because those segments would be perpendicular to the radius OL and perpendicular to the radius ON. So now we have this equation where the sum of the measures of these angles, 117 and 90, and x and 90, the sum of the measures of these angles in this quadrilateral is 360. And so we can create an equation using stuff that we know from first semester or in the beginning part of this semester to be able to find the measure of this angle. I would like for you to solve. All right? Over here, find x, knowing that DE is tangent to circle O at point D. That means that this is a right angle, which means that I have the triangle angle sum theorem. 90 plus x plus 38 is equal to 180, or you can just use the two acute angles are going to be complementary. All right, so either add them up to equal 180. If I subtract 90, I get this equation here, but then that tells me that x is equal to 52. All right? And so the goal there is, can we create some equations based on stuff that we already know and use this new piece of information that if I have tangent segments, that means I'm making right angles. I'm making right angles, which means that I've got 90-degree angles, and we can create and solve equations that way. All right, or we can have kind of this magical moment right here. Now the algebra that we're going to do here might seem a little bit staggering, all right? It's chapter 9 of Algebra 1. It's been a hot minute since you've done that. But right here, find x given that ST is tangent to the circle. So that means that I have a right triangle where I know that a squared plus b squared is going to equal the whole c squared, right? So if this is side C, that's side A, that's side B, then I can find the measure of, or the value for x by using the Pythagorean theorem. So here is my right triangle. This is the hypotenuse. So this is where C is. And here's the interesting thing. I know that the radius is x. So this distance is x, this distance is x. But this whole distance, this whole hypotenuse is x plus 18. So the whole hypotenuse is x plus 18, and that's what I've got to square. A is going to be x, B is going to be 24. And we're going to get to do a little bit of work here in the calculator. X squared is just x squared. 24 squared is 576. All right? We can just double check that. 24 squared gives us 576. Now, x plus 18 squared is not x squared and 18 squared. That's not how that works. X plus 18 squared means we're taking x plus 18 and we're multiplying it by x plus 18. We have to do that double distribution. Your Algebra 1 or pre-algebra teacher might have called that FOIL. But when I'm doing x times x plus 18, and I'm doing 18, times x plus 18, my work is going to look like this, and we're going to do double distribution. So I get x squared, I get 18x's, I get another 18x's, and I get 324, which is 18 times 18. All right, now I need to solve this equation. I do have some like terms I can combine. I can also get rid of my x squareds. If I subtract x squareds from both sides, they're canceling out. I'm left with 36x's and 324 is equal to 576. So we're going to subtract 324 to get 252 is equal to 36x's, which gives me 7. So I find that the radius of this circle is 7. Now this is a lot of Algebra 1. Most of our Algebra 1 that we've done this year has been like 2 or 3 steps. We've got our formula, we plug in the numbers. This maybe wrote that out a little bit longer than we needed to. Many of us can FOIL that out just fine. We can do our double distribution, x squared plus 2 18x's, so 36x's plus 18 squared. And then we can solve that equation accordingly. So this obviously might take you longer. If you write out more steps, it might take you less. If you write out less, you have fewer steps. But at the end of the day, we just have to be able to do that Algebra 1 to solve that equation. We are not solving the quadratic equation here. I know this looks like a quadratic equation, but these x squareds are eliminated. So this is really just a linear equation. All right, we don't have to do quadratic formula or anything crazy. All right, so let me know what questions you have on that. I'd love to hear your questions. All right, example 3. Here we're going to ask the question, so using the converse of that theorem, how can we show that this segment is tangent to the circle? Well, if it's tangent, then this would have to be a right angle. How can I check if this is a right angle? Well, I would have to say that this would have to fulfill the Pythagorean theorem. Does c squared equal a squared plus b squared, right? The converse of the Pythagorean theorem states that if c squared equals a squared plus b squared, then this triangle is a right triangle. So does 25 squared equal 7 squared plus 24 squared? All right, so does 625 equal 49 plus 576? It does. So yes, ML is tangent to circle N. And there's my supporting work. All right, over here for example 3b, let's call this A and let's call this B. We are going to ask the question, is MP, I'm not concerned about K, I'm not concerned about this, is NP tangent to circle N? What is the measure of this angle? Is it 90 degrees? So we can find that by taking the measure of angle NMP plus 58 plus 33, and we know that that has to equal 180. In this triangle, that has to add up to 180 degrees. The question is this going to be 90? All right? And we can tell already that it's not going to be, whoops, NMP. When I add these up, I get 91, which means that the measure of angle NMP is 89. It is not quite 90. Therefore, MP is not tangent to the circle. To circle it. All right, so we have that thinking and we have that work that supports our thinking. It doesn't do us any good to just answer yes or no without supporting our answer. We want to be able to explain to our teacher, to ourselves, to our neighbors, why it is or is not tangent to the circle. All right, theorem 10.2. So that was theorem 10.1, working with right angles. Now theorem 10.2. Basically, this is kind of a neat trick. But if we have two segments that meet outside of the circle, if these are tangent segments, then they have to be congruent. So if AB is tangent to circle P and if AC is tangent to circle P, then these segments are congruent. And here's the explanation of why. We know that these segments are congruent, and we know that that segment is congruent to itself. These are tangent, so we know that these are right angles, and this is a right triangle where the hypotenuses and the legs are congruent. So by hypotenuse leg, these triangles are congruent. And if these triangles are congruent, then segment AB is congruent to segment AC. There's an explanation for why that's true. And now we are going to use that. All right, now this is a little bit complicated because the number one concern is this. PX is not congruent to XQ. Or PX, the length of PX, is not equal to the length of XQ. This and this are not equal to each other. These are different lengths. All right? These are congruent, and these are congruent, but these are not. Not necessarily. They might be, they could be, but that is not the case here. So, what we're going to have to do is we're going to have to recognize that PX and PZ are congruent, so this is going to be 15. ZR and YR are congruent, so this is going to be 17. And then we have to figure out what this is. All right? So we're going to try to solve for the length of QY. QY and XQ are the same thing. Let's give them, we've already used X in this, so let's just call this like A or something. This is A, and this is also A. So I'm going to have an equation here. Circle O is inscribed in this triangle. The triangle has this perimeter. The perimeter is going to be the lengths of the sides added up. So PX and XQ, that's one side. And then QY and YR, that's another side. And then this third side is RZ and ZP added together. Well, I know that this perimeter is 88. PX is 15. I don't know XQ. I don't know QY, but I do know YR. I don't know RZ, but I do know ZP. And the parentheses are kind of irrelevant, right? So here I have 18 is equal to, this is 30 and 34. Excuse me. And so this gives me this sum. I've got 64 and 2 of these A's. When I subtract my 64 from both sides, I get 24 is equal to 2A, which means that 12 is equal to A. All right, so we created an equation, we solved an equation. Now, do you have to write all this out? Probably not. You're just going to add the lengths of the sides. So we've got 2 of these 15s, 2 of these 17s, and 2 of these A's. That's important to recognize. It doesn't mean that A is 15. In fact, we just showed that A is not 15. So this part is not equal to that part. Rather, these two pieces are equal to each other. All right, because they are segments that are meeting at a point outside of the circle. They are tangent to the circle, therefore, and therefore they are congruent to each other. All right, so that brings us to the end of this lesson. Hopefully you can use these properties of tangent lines, the angles specifically that is formed there at the point of tangency, to create and solve equations.